Recording has started. I'm not repeating the introduction, but now the floor is yours, and we are all ears.
Okay. Yeah, thank you for the introduction. Well, just to tell a little bit about myself first, as you requested, I worked for 15 years for the Belgian Railway Infrastructure Manager. I did many different types of data projects, both in data acquisition with measurement trains, as in data processing. And the last 2 or 3 years of my career at Infrabel, I started to get more and more into the RDF world. And at some point, I decided to become a freelancer for railway data with a big focus on the semantic value of it, the RDF and everything around it. So that's how I ended up with Bane NOR, which is the Norwegian Railway Infrastructure Manager. And they are doing a project building a knowledge graph. I will talk about that. Yeah, well, we have lots of different issues with tooling with everywhere, also with Sparkle Anything, and we try to not just complain about these things, but really also contribute to a better world, let's say. So I will start by sharing one of the screens or one of the windows. This one, yes, that should be it. So I followed the example of Ivo and Salvador in using good tooling for making presentations that a bit more open source and more useful to digest later. So yeah, we are building a knowledge graph for railway infrastructure. And one of the tools that we use is Sparkle Anything to accomplish this. Let me divide this presentation in three parts. So I would first like to say a little bit why we are doing this project, what is the business value of it. And secondly, I'll go into detail about the technical implementation. And lastly, I also have a couple of wishes or things that would make our life easier. And then not because I want to give these wishes to you to implement, but just in general, as things that we struggle with and would like to see fixed at some point. So why build the knowledge graph for railway infrastructure? That is because the railway system is actually a very complex system, and it is often underestimated. Just to make sure that we are not going too far into details, the railway infrastructure, the system has a lot of actors like infrastructure managers, railway undertaking station managers, industry connections, and so on and so on. That are all different roles in this system. And here we are focusing on the railway infrastructure manager. So that's the one that is, its real purpose is in creating and selling capacity on the railway network. And it has to do that by building, maintaining, operating many kilometers of track and different assets. And typically inside of this railway infrastructure manager, there are by itself a lot of domains. So we have the asset maintenance, which sounds very obvious. Of course, you have a lot of kilometers of track, they need to be maintained. Also typically is that you have track, you have catenary, you have signaling. They are divided in the company by different divisions, and they all have their own way of inventorizing. Then as a separate domain or use case, you have infrastructure projects that are trying to add additional infrastructure or upgrade existing infrastructure. Operations, where they really operate a train. They say, okay, now this train can go from point A to B. And in order to do that, I need to set a route that flips switches. Or I need to do capacity management. Okay, I need to do works on this line, so I need to reroute trains or set up some other kind of service. and type tabling simulations. Yeah, so the operations is quite a diverse environment as well, with lots of subdomains in itself. We also have stakeholder communication. So whatever is done on the network, when a certain line is out of service, it needs to be communicated to these stakeholders. And next to all of this railway-specific complexity, there is also the complexity of just the normal corporate functions that you will find everywhere: finance, HR, clients, contracts, procurement. These things are very similar to other companies, yet they add the complexity of the railway system. And all of these depend on, well, sources of truth. They need infrastructure data. And generally, when you have this big system where all the different entities are interconnected to each other in some way, and I try to represent this a little bit in the schematic, the power or the real added value is in these connections between them. It's when you can connect the financial part with the investments, with the infrastructure, with the trains that are driving. In order to do cost-benefit analysis, well, you need the costs and the benefits. You need to put both together. And unfortunately, when you have the kind of company or system that is from 200 years ago and has continuously built up, well, these different use cases, they tend to make their own thing. And you will see that in the company, each use case has its own, well, data silo. And the word has fallen, a data silo. They want to solve their own problem, their own use case, and they need infrastructure data. Well, they will try to get the infrastructure data from somewhere and then model it according to what they need and disregard anything else, disregard the entire complexity of how all those things are interconnected. Yes, that's what I was saying. And so historically, you have these different use cases with their own database. You sometimes when you compare different infrastructure views, you would think that you're talking about a different kind of infrastructure and not the same. And it's really when you capture the details, okay, this is about a micro topology situation, a micro view on the network, and this is about a macro view on the network. It's then that you start to realize, okay, they are talking about the same thing, but on a different scale. So we have this vision with a unified model. So get everything inside of the same knowledge graph, the same definition of the railway infrastructure to serve really as the reference data that all the use cases require, need, and to operate on in such a way that they talk the same language. Well, not only the same language, but talk about the right things in the same language. So yeah, that's a bit the vision. What the goal of the project is in a very long-term future. Currently, we have this RailML bridge. Let's say RailML is an XSD schema, so built on top of XML, and it is already maybe 20, almost 25 years old. That it started as a community project, also open source, but it is not free and open source. There is a certain license bound to it. But it defines how you should structure your data in order to be suitable to be used by many use cases. And that has been picked up by some use cases. So they are currently able to ingest a RailML file and perform the use case based on this RailML file. So for us, it makes a lot of sense to use this this thing to create a RailML file and make sure that the other use cases take this RailML file and use it, and that they don't define their infrastructure on themselves, but that they reuse a definition of the infrastructure. So we call this a RailML bridge. We try to go from near term, okay, here is a RailML file, to a long-term future where they are really consuming RDF. So we, as the project, we create a knowledge graph, and the idea is that we generate RailML files that feed existing tools. But in the future, we would like this direct interface with the knowledge graph, of course. So maybe first, is there any question from you about this business case? Feel free to interrupt if there is anything. Yeah. So about the technical implementation. Now, the thing with our current situation is that we have a young team that has never before really built a knowledge graph. So for us, it was a little bit trial and error in a lot of ways. This entire pipeline that we built, it was very much grown organically, and a bit the same as the problem with the use cases. You try things, and last month you discovered that there is a better way of doing it, of which we thank this group for this information. So what you will see here, I try to make a kind of history. Okay, we started here, we added this, and then that, and so on, to give you kind of an idea of the problems that we stumbled upon. So to begin with, the vision is that we need to do is very simple. We have multiple source systems. We create a knowledge graph. From that, we create RailML files, and we feed it to the use cases. The source systems are very heterogeneously. They have different aspects that we need to take into account. We all unify them in a single knowledge graph, and from that, we generate RailML files. But then, what do we actually have to build? So, as I said, the team was new. We evaluated a couple of options, and I wasn't there when the decision was made, but it was chosen to use SPARQL Anything because of, they needed to learn SPARQL anyway, so it doesn't really make sense to learn RML or Otter or any or implement any custom code, but that is obvious, of course. What you can do with standards is better to be done by standards. Our primary source formats at the time of this decision were XML and CSV. So we develop and construct these construct queries using SPARQL Anything in a Yashui interface on this SPARQL Anything server, and everything is deployed in the Kubernetes cluster, and that works pretty well. Except we had a little bit of problems. So we had in 8 steps. I'm going to demonstrate how this evolved into what it is at the moment. So we really started with these XML files, the RailML files that are currently produced by the source systems. We convert into Turtle, and that initially worked pretty well until we found out that those things don't contain a topology. And we need topology. We need a topology because of the advantages that it gives in unifying everything into one view and making it available for the use cases. Now, what is a topology? That is okay. So this topology is not available in RailML, but it is available in another kind of export format that was also available from one of the source systems, and that is called OpenTNF. Now, I'm juggling a bit with different file formats. In this case, OpenTNF is actually kind of an extension on GeoSparkle. And GeoSparkle is an extension of SQLite. So we have these different standards that are built on top of each other, but in the end, it's a SQL database. And the advantage of it is that it contains the topology at the core. So we don't need to reconstruct it or build it from somewhere else. We can just map it and ingest it in this way. The topology of the railway, it can be defined in many different ways. One way, the OpenTNF way, is to classify switches and ends of track as nodes, and then connections between them are the tracks or links or edges. Another way of modeling it using another format, RTM, and RTM is the base of RailML. RTM stands for Rail Topo Model. That defines tracks as nodes and the relations between the tracks, how you can navigate from one to the other as the edges, as the relations. So this topology is really meant to be a foundation that is separate from the real definition of the word track or the word switch. And the advantage of a model like RTM is that it's not only a microscopic one where it switch from switch to switch, but it can also be scaled up to macroscopic views from station to station. And a second advantage is every asset that you want to position, well, you can do that by intrinsic coordinates, 1D coordinates. You define the link, the track or the node in the topology on which it is located with an intrinsic coordinate. That's a 1D way of locating things. So why is this topology important? I already said it, unambiguous positioning. You don't need to rely on kilometer poles or names of tracks in some source system that changes every year. It's unambiguous, a precise and unique location. You have clear navigability. You can define how you can go from point A to B, something that is very important for route analysis. And when you use Google Maps to go from with a route planner from A to B, that it's also in a graph-like network that it works to find the shortest path or the fastest time. And these things, well, when you have this as a solid as a foundation of your data architecture, then you can also support those use cases. Things not strings. So instead of using human readable names for tracks and kilometer poles, you actually define entities for these things and disregard the labels that people give to them. Yeah, so what I said before, this topology is very much a foundation for if you want to map the different source systems together. They all speak their own language, and it's mostly not based on a topology. Well, make an abstraction of that language, create the topology from them, and then map the topologies, and you will have mapped the source systems, at least in terms of positioning. So we come to a problem. Sparkle Anything, well, if you have this SQL file, this SQLite, Sparkle Anything doesn't work with databases. So the first complexity happens. We need to add what we call a source ingester that converts a SQL database into a CSV file, and then we can let Sparkle Anything loose on it. It's not a difficult thing to add, it's just another step. So now we are at the point where we are constructing our mapping files asset by asset. So most of the time, one CSV file will be one asset class and an asset type such as a switch or a single. We convert it with Sparkle Anything and we start mapping it using construct queries. In total, we have about 40 asset types for one source system at the moment. And this is how such a mapping file looks like. So you have the construct part, and here the service clause to Sparkle Anything, where we immediately start by creating variables with a more common name, RailML name. So a designator is something that is used in the RailML ontology. And we start binding things to create IRIs. Now we created turtle files. We load them into Jena. So yeah, you really take the TTL file and you use the TDB loader from Jena to create a new TDB dataset. And in order to get this into the right endpoint, we needed to do some hot swapping. So of course we want this Physeki to be live all the time. So the endpoint shouldn't be taken offline during an hour for the ETL process to finish and then come back online. No, it's something that is hot swappable. So we create a new data set, and once everything is finished, we point the data files to this new data set. So the schema becomes a little bit more complicated. At the end, we add Jena Physeki. And then the next problem, we discovered that not everything can be done with Sparkle Anything, or at the situation where we have these mapping files. The construct part is not enough. We need some more. We have called this post-processing, but in fact, you could also call these things that inferencing triples, or Shekel, something you can do with Shekel rules. I'll drop the word immediately. So it's like cross-file mapping rules. It's not so easy to use nested Sparkle Anything service clauses, because that can create performance issues. So that's something that is better done in a post-processing step. Some generalized actions when you want to perform the same action on all the on multiple mapping files instead of on one, to avoid copy pasting. When you want to map ontologies, so we need to support both RailML and ERA. ERA is the European Railway Agency. Yeah, that's also a step that is more logical to be done after the mapping. And in total, we currently have 50 of those post-processing queries, and they are in the form of an insert and delete. So update queries that we launch on the Jena Physeki dataset. And they are numbered, so the execution order is important. So this is complexifying the process again. And this is an example where we infer that a RailML net element is actually the same as what ERA calls a linear element, and we need to do some changing of the data type. Yes, I see a question, Enrico.
No, just one clarification. I think if you move to the previous slide a second, please. Yeah, I think one of the one of the issues you mentioned is about having to generate multiple ontologies with from the same mapping somehow, no?
Yes. Yeah.
I wonder whether you tried doing a query for the selecting and then reusing the query in different construct queries, because that's something that I think we can do now with Sparkle Anything. So the idea of using a query as an input, and then you don't have to write two queries that do the same thing somehow. Yeah. If this makes sense.
Yeah, that makes sense. That's interesting. Yeah, that could be interesting to look at, indeed. Yeah.
But I think you touch an important point, which is how hard it is to reuse Sparkle queries in general, or fragment thereof, no? Because one may want to do more things with one single mapping. Okay.
Yeah.
Sorry.
Yeah, it's also part of kind of a separation of concern when you first map everything to one ontology, and the ReLML ontology in our case, which makes the most sense in our case because we need to produce these ReLML files. And you have this second thing that you also need to support, the ERA ontology. When you put that in a separate box, and you don't care about now, but you care about at a later stage, then you can start mapping the ReLML ontology to the ERA ontology. Yeah. Yeah, so I said that. Okay, so and then we have this cross-file dependency. So we need to, of course, first do A in post-processing and then do B. Yeah, and this is an example where we define, we first need to define area locations for what we call subnetworks. I'll give a little bit more information on that later, before we can say, okay, this entity is part of this subnetwork. So in what this first file will be doing is creating these triples, this association of the subnetwork on the topology. And of course, you need that first before you can map the is part of the other banner. But yeah, and so like this, we have lots of dependencies that we currently annotate just with comments. Okay, before you execute this update SPARQL file, you first need to do the other one. And of course, this would be much more logical when you use a shekel rule, even if it just implements a SPARQL query like this. Yeah, then adding the order makes much more sense than having this kind of comment. And then the next step, we also need to do pre-processing in SQL. And this is actually one of the biggest frustrations that I have with SPARQL, and mainly GeoSPARQL, and also how it is implemented in Jena. It cannot always do all the functions, spatial functions that we require. So in order to fix this, to do it anyway, we do it in SQL instead of in RDF, in SPARQL. An example of this is, well, I gave you a couple of functions that are not available in GeoSPARQL. Even the most basic ones, like get the X and Y coordinate, okay, my mouse is very slow. Even getting the X and Y coordinates is not supported in GeoSPARQL. And thus not necessarily implemented in the same way in all the triple stores. And everything relating to linear referencing, all these functions, well, yeah, forget about them. They are available in PostGIS or in SQL Spatialite. So it's there where we actually perform these functions in order to get the triples that we require. Such as, yeah, defining the switch branch direction. So if you have a switch, it will split the track in two parts. Which one is left, which one is right? It requires calculating the azimuth and having the substring. One example. Oh, and this was a question while I created the slides. Another purpose for which we do pre-processing in SQL is we have sometimes XML content inside of a column in SQL. And when we export this into CSV, you have XML into a CSV file. So I don't know of a way to do this with SPARQL anything that we can parse XML content of a CSV file. Is it possible?
In principle, yes. So we have the case, for example, when with JSON long collection of JSON files, in a single line separated file. It's a plist, I think, or something like that, a JSON list, I don't know. then you can do the first parsing of in this case is a CSV, right? That contains XML value.
Yeah.
And then you can pass the XML value to to a nested service clause with the clause fx content instead of location.
Okay.
And then you put the content of the variable. You have to rename to kind of pass the variable to another binding in order for this to fix, but there are a few examples. Maybe later we can
okay. Now I remember the content, fx content. Yeah, that's what we need in this case. So we misused it this a bit, but yeah, because of ignorance from our side. So that's another block that we need to add to this entire schema. And yeah, then you have these kinds of SQL queries that you need to add where, like I said, line substring, azimuth, and all these kinds of spatial functions. And they typically also are very much using nested queries or the with statements. Can't remember the name for it. And another complexity is data patches. Now, we discover data quality issues in the source systems, and they tend to take a long time to fix. So instead of waiting for them, we want to fix them already so that they are available in the knowledge graph. However, that's not always so simple to be done in some step. You need to know, okay, when I change it here, it will impact also those SQL views that I'm creating and everything else. So the right place to do it. So we decided to make it happen even before anything else. We first fix the source file, the OpenTNF file, and then we perform the entire ETL in order to avoid the complexity of doing it later. And it can be very complex. So yeah, this is adding again a step to this entire process. I'm going to give you here one example just so you appreciate a little bit the complexity of the Layerware network, something that we call a double switch node. That is, you have two physical switches, track switches, so that can split the track on the same topology node. Then you don't know when you only have this information, which one is the left one, which one is the right one, and so which one has which branch. So it's shown a bit here. This is the initial situation, but the ontology model, sorry, the topology model that we use requires to have two nodes, so one node per switch. So one of the processes that we do, the pre-processing, is to add this new link in between that has no length, just to separate both of them in a logical way. And we have about 40 of such patches. It's not a unique situation. There are much more. Yeah, and then a SQL example. And then lastly, we split the knowledge graph. So we have a very big knowledge graph of the entire network, but that would create an XML file of, I think it was 300 megabytes at the moment. So it's a very big one, and it cannot be ingested by all the by every tool. And the primary tool that our customer uses is more used to work with smaller LML files up until 30 megabytes or something. So we split the network into smaller sections. We actually did this by creating polygons in a GIS program and then adding those polygons onto the topology. And once we have the definition of such a subnetwork inside of the topology, then we need to say, okay, now I want to have a knowledge graph specifically for this region, this topological region. But then the fun begins, and you need to create a Sparkle query for it. And at the beginning, you're a bit ignorant, you don't have a lot of experience, so you start working with a lot of optional classes. You execute, and it takes 2 hours for one query to be executed. That's not workable, of course, so you try to find optimizations for these things. And in the end, now when we run, I think we have about 20 or 30 subnetworks. When we run everything in parallel, it takes about 25 minutes for it to be done. But to do this with Jenna, we actually copy the data sets, the TDB data sets, and then we use TDB query to execute all those splitting queries on individual data sets. But again, the ETL becomes a little bit larger. And this is an example. So you have the subnetwork that is defined as what is called in topology terms an area location. And that area location, by a couple of steps, is linking to what is called net elements. So that are the nodes in the topology. And then you're looking for, of course, all the properties of those net elements. And if they are objects that are defined here, so your eyes by themselves, then you need to also have the properties of those properties. So we need to go a little bit further. And the same union with then things that are linked to them, such as you have nodes and links, the relations in this case. So you union a bit more to get a part of the topology splitted. And like this, we have 15 queries. Some are a bit bigger than others. And in order to orchestrate this entire ETL job, we are using Airflow, which is Apache Airflow. It's an open source tool that works. We have a good experience with this to orchestrate everything. So it now looks a little bit like this. I simplified the schema a little bit. That's how the processing works. So that's the technical side, part 2. Part 3, where we're headed and what we wish for. I already voiced a couple of those things. So I really liked the presentation given the last time by Ivo and Salvador. So this one-eyed graph approach and then Shekel rules that would already simplify the schema a bit and allow us to add things like data lineage, the provenance information, and yeah, just making everything a bit better maintainable. And another thing on our wish list is, of course, more GeoSparkle that is more extended with linear referencing and routing. And of course, the implementation of those functions into different triple store or Sparkle processors. Then Shekel rules engine, of course, as far as that allows to do easy thing that allows to make it easier to do data lineage and to do analysis on how everything expands when you're performing a certain rule. Of course, better Shekel validation. Yeah, we are in this industry setting, and just having the Shekel validation reports, it's nice, of course, but you need to visualize it into a dashboard or something that can be better used and investigated, analyzed, and going back to the source in collaboration with the Shekel rules. Okay, so you have a problem in the end, but from where does it come? And then, yeah, the referencing application, which is based on Shekel definitions. Okay, if you have a URI, you click on the link, just give me a page with relevant information. So simplified future pipeline would look like this, where let's say Sparkle Anything can access directly the source systems without having to do an intermediate step of CSV files, without the need for any SQL fixes, because everything can be done with spatial functions in Shekel, in Sparkle or in Shekel, where we then have our target knowledge graph that contains all those rules, the data lineage, and everything else. And then lastly, I wanted to just show a website that we recently launched last week, actually, that for us serves as a lighthouse project where we show how it's possible to build an application on top of a Sparkle endpoint. So we purposely decided not to use Node.js backend or some other API as backend, but directly work on the Sparkle endpoint. And that's what is created here. So of course, this is an enterprise environment, so you need to log in. And else you can only access the front page to get some more information on the project. But if you were to log in, I think I'll... Okay, perfect. Then by just to show you that I'm not saying anything untrue, if you refresh, you will see a Sparkle call happening over here with a Sparkle query as payload and the response that comes back. And that is then handled by the JavaScript, of course, to put into this nice table where the user can download a RailML file. And at the same time, we offer a couple of tools to explore this knowledge graph that we've created, that they don't stay stuck with XML files. And one of the tools is SparNatural, where we have defined also a couple of example queries, and the user is able to visualize this one and explore in general the knowledge graph. The only thing missing here is when you click on one of those URIs, you will get served with a 404, and that's something we need to work on. So yeah, summary, we think Sparkle Anything is a very good tool for knowledge graph construction, even for teams that are new to RDF, like we were. The source ingestion pattern is just a practical workaround until other things are solved. Topology is key for railway data, definitely. And then we think that this one-eyed graph approach with Jekyll rules is definitely the next step in our story. Questions? Thank you.
Silent, non-silent applause from me. So thank you very much. This was really, really interesting. We can start with a round of questions. Luigi, you want to start?
Yes. I just want, first of all, thank Matthias for his very nice presentation. Also, give us a quite great overview over this topic. I just have a question. Why about the RailML to Evo? Evo, I think, Era Transformer. Yeah, Era Transformer. Why don't you define just I assume that the two models are equivalent in terms of semantic concepts. So they both contain quite the same concepts. Why don't you do just an RDF to RDF transformation? Why do you need the source, for example, for extracting more information that can be populated in the Era ontology? Or if they are equivalent, why just create a construct that transform from RailML to Era ontology?
Yeah, that's a very good question. So our team has the assignment to create RailML files. So it makes it logical to put the knowledge graph into RailML ontology and then have this Python script that takes everything from the knowledge graph and puts it into right elements in the XML. But at the same time, we also have the requirement to publish the RINF, which is the Register of Infrastructure. And that is according to the ontology of Era. So we also need to export the triples from the knowledge graph according to the ontology of ERA. I guess you could also not put these inferred triples that certain entities bought a switch according to RealML and a switch according to ERA. You could also disregard one of the two and do it at the moment that you export the knowledge graph for ERA. But at the same time, this also allows to create more semantic interoperability, I guess, to see, okay, this entity is both a switch according to this vocabulary and a switch according to that vocabulary. So it's just an approach, a decision taken to put everything inside of the same knowledge graph.
Oh, okay, that makes sense. And the other was consideration about the GeoSparkle functions that you need, that you find in other systems, databases. So why don't we propose, or you propose these kind of functions to Jena? I think that Apache Jena may benefit from it, since there is also the evidence of other DBMS systems implementing functions. Maybe the Jena community also would benefit of it. Otherwise, we can implement it in Sparkle anything, but maybe I think that is more appropriate to implement it in Jena.
Yeah, that's completely correct. The wishes and so on were not specifically for Sparkle anything. It is very, very true that the Jena community will benefit from these spatial functions to be added. I also see that there is another group that is very active in the spatial, enhancing Jena in a spatial way. And I already fixed things in Jena that I found out about problems with current supported functions. We just haven't gotten around to adding functions to it, but at some point we will. The idea is also to first maybe experiment with some user-defined functions that we take separately at the moment, and then a little bit like we worked with Sparkle Everything. We add functionality, we test it locally, and then we give it back to the community. So that is certainly on the roadmap. If I give you a short answer, just because we haven't had time yet, but certainly something we want to do.
Yeah. Okay, thank you. Great presentation.
Thank you.
So I have also a question. It was a really interesting presentation, and it's clear that the whole ETL process is always very complicated when you put it in practice, because data is messy, because things are never the way you want them to be. But you haven't talked a lot about the scale. So I was wondering if you could tell something about how much data this project had to deal with, and if this affected in any way your design of the ETL process.
So we are currently at a knowledge graph of 8.4 million triples. I think that's the first scale you can think of. I have other slides. So here in the presentations, this one is from November. We also have, of course, some more detail about some things and an idea of the scale.
So when you run, for example, I'm curious, when you run Sparkle anything, how do you configure the JVM? Do you use the default configuration, or do you allocate more heap size? You ever had any problem with?
We did have problems with memory. That's a good question. So everything runs on Kubernetes. So you scale. We can easily see how the the containers are performing, if they need more memory or not. And you synchronize, of course, the the memory that you give to Java according to what you give to the container. So there are in I could show the deployment scripts of Jenna. It's a constant juggle of giving resources to everything. One of the issues that we found there, and that is also a bit annoying about Jenna, is that it is single-threaded, or at least I'm not sure if it's truly completely single-threaded, but it doesn't use a lot of threads in any case. So adding more processor power to it, multiple processors, will not help. When you want to scale a problem like splitting into multiple subnetworks, we copy the data set of Jenna, and we launch multiple processes ourselves on the data sets.
But that's TDB2.
Yes.
Yeah, that's TDB. Yeah,
TDB2.
Well, instead, on the side of Spark or anything, you don't think you had any. For example, you didn't have to deal with very large CSV files, for example, or you never hit some issues in terms of RAM required. I'm asking because one of
yes, we also did, and we also implemented some fixes over there. If you want specifics about our current, I just need a moment to look it up.
Just to give a bit of background to my question, I mean, one of the discussions that the limitations we have now on Spark or anything is on the fact that the main approach is by materializing the entire graph before executing the query. So there is the obvious limitation that goes with the size of your memory. So if you have a very large input file, you need a lot of RAM to hold all the graph in memory before executing the query.
Yeah. So we currently have,
and because we are studying with Luigi ways to get around this and use less resources, I'm kind of curious to touch how important that will be.
Yeah. So let me give you just an impression, and then you have kind of a benchmark. So our current no, I need to be careful here. So this is the server deployment script that's on which we test mapping files. So this one only has 8 gigabytes of memory.
Yeah.
Yes, but it is not the one that is used in the production ETL jobs. For that, we use the worker of Airflow, and that one has got 24 gigabytes of memory.
Nice, interesting.
Interesting. But I don't think we need all that memory for the Spark or anything part. We mainly need it for the post-processing steps.
Of course. Okay, no, thank you. This is already interesting.
I could look up the size of the CSV files if you're interested in that.
That would be great. Maybe we can also keep this in a conversation by email, because I'll be curious to get a bit more details about the whole infrastructure. So anybody else want to have any questions or comment? Okay, so I think this was really interesting. We also use almost all our time, which is good because I personally haven't done much progress on the specifications. I don't know, Luigi, if you want to say something about, or you have any other comments?
No, I don't have also progress on specification. I just want to open a discussion on how we can, how the group can contribute to the specification. How can we see a process? Maybe we have done some work on the specification. How can we involve all the whole group in working in the specification? I don't know if you have any suggestion on that. Specification are there, so of course you can read it and suggest modifications. But if you have any other more specific process of reviewing, I don't know, I'm of course open to it.
So Ivo sent just a commented on the chat that he has made some inline comment with hypothesis.
Okay, great.
Yes, which I don't know, but I'll look it up.
Yeah, okay.
That could be one. Yeah.
How can I access to the comments? They are integrated in GitHub or not? Maybe we can open an issue to reference the hypothesis comments. I don't know. Maybe we can.
Can you hear me now?
Yeah.
All right. So something happens with my camera, and because both has camera and microphone, that's why you cannot hear me. So I have submitted an issue about this, where I suggest three options, maybe there are more, which we can use. One option would be to keep the draft as a pull request, so that we can make comments on a particular line and keep it like that for quite some time. That would be one option. Another option is there is a tool that works directly with GitHub and otherwise have functionality like Google Docs, so people can collaborate with comments and suggestions. That's also there. And the third is something that I have used a lot, is Hypothesis. It's again a free tool using, by the way, W3C's annotation standard for making a layer on top of any HTML document. So in that case, I created a group, and anyone within the group can make comments and see comments of others, which can be highlights, annotations, and you can respond to comments with other comments. So it works like this. So these are three options that I have experienced. I don't have any preference, but it was easier for me, since it wasn't in a pull request, to create this hypothesis group. It doesn't mean that I would like to impose any of the three options.
Yeah, thank you. Me neither, actually. So if you have any experience with that, I'm very open to all of three options. I don't know if any of you have experience with one of that. Of course, GitHub pull requests are
absolutely fine. I think any technique is fine. I think it's good we started. Yeah. Thank you, Ivo, for the feedback. We will react soon. Anybody else, please join the GitHub organization or send us an email so that we can keep building that. Okay, so next meeting, let's fix the date, which should be, if we are all happy as usual, the second week in March. Will be 9th of March. Interestingly, I think the invite is already there. We are working for the next presenter. I think we don't have a name yet, but we will share that soon. And in the meantime, thanks again, Matthias, for your presentation and your time that you dedicated to us today, and the discussion. Thanks everybody again for joining, and we'll be in touch with the minutes, the videos, and the next announcements.
Yeah.
Okay, so Ivo, you say we have Maplib then. I was waiting for your confirmation. So it's confirmed.
I sent you the confirmation and also forwarded the invitation to Magnus.
Fantastic. Sorry. Okay. I may have missed that. Last week was a bit off. Okay. Thanks everybody then. Everything is fixed. See you next month.
Thank you.
Enjoy the rest of the week. Bye-bye.
Bye.